This meeting is being recorded.
In Chapter 2, Problem 17, you may have noticed a pattern. Every time we created a residence structure, so we saw transformation from 2A to 2B and 2A to 2C. If you take a look at problem 17. So now we're asked to locate that pattern that we learned in the last problem, and that pattern is lone pair next to a pi bond. So each of these molecules here, A through E, will have this pattern, this lone pair next to a pi bond, and then we'll draw the curved arrows, and we'll take a look at the resultant resonance structure that I already have drawn down here. Oh, we forgot the arrow here for this one. So let's take a look at A. So we should have here 2 lone pairs on each oxygen. So what we have here is a lone pair next to a double bond, a pi bond. So these lone pair electrons will move in here. Those will cause, that movement rather will cause these pi electrons involved in this carbonyl bond to move up to the oxygen. And then we see the structure down here that results is a 3-bond, 1 lone pair on an oxygen. So that has a positive formal charge, and this oxygen up top has a -1 formal charge. Let's take a look at structure B. And again, we're going to have 2 arrows in our movement here. So we have a lone pair indicated by that -1 formal charge on that carbon. So those will move here. That will form the double bond that you see in the solution down there. But that will trigger, right, the movement of these pi electrons to this carbon here, and that's the lone pair on that carbon, which results in this -1 formal charge. So in molecule C, we have lone pair here on the oxygen, which is next to our pi bond. So again, we will see this pattern. So movement here forms the double bond we see below, and then we'll have the double bond here, that pi bond. Those electrons will move up to be on that carbon. So we'll see a negative formal charge with a lone pair on the carbon, and then we'll see a +1 formal charge on the oxygen now. In figure D, we see, again, we have a lone pair on the nitrogen now next to a pi bond. So let's move that lone pair here. Now we see the double bond down below. Nitrogen gains a +1 formal charge, and that causes the double bond here to move electrons to that carbon there. And then we see in the answer below, the resonance structure has a lone pair on the carbon and a -1 formal charge. For our last compound here, we see lone pairs, 3 lone pairs on this oxygen next to a double bond. So what we have, this lone pair goes here. This oxygen already had 2 lone pairs, so a third will be deposited. So down here we'll see a negative formal charge on our oxygen, 3 lone pairs, and then this oxygen now is neutral and only has 2 bonds and 2 lone pairs, but that nitrogen remained with a +1 formal charge.